want to hit the light back there to get a better view.
Drop her together.
Corinne, can you hit the?
Sorry.
She's busy. Got me.
Yeah, sorry about that. It's a little bit better to see now.
We're putting out fires.
Actual fires?
No.
But that's a likely
Actual
that's
fires?
a likely thing. So.
This group knows now I like fires.
Let's
So,
measure the particles released.
so this is a BAM instrument that we're talking about right now, as we keep mentioning. It's like beta attenuation something with an M. Can't remember right now. So this is your nice fancy, $100,000 analyzer. You've got your size selective particle inlet here. This one is set up for PM10. So basically it's filtering out particles that are larger than that, and only those that are smaller are coming through. It's getting pulled in through an inlet. This is just a water trap to help get rid of any moisture that might be in there, because you want an actual measurement of the particle. Comes into this analyzer, does the measurement here over the hour, and what you can see here is each one of these little dots is just that. It's this actually might be a picture that I took in San Rafael after the fire that I was just talking about. You could see how dark some of the things are. So it was one of the days that the smoke was particularly bad. This uses like a tape measurement. So basically you've got an oven in here, you got a piece of tape that's going through, and it's doing a measurement on a dot each time, and it's moving forward every hour. And that's how it's giving you a concentration every time. So again, these are kind of expensive but pretty accurate methods for doing PM concentration measurement. There's some other equipment we have here. You can see an anemometer. It's measuring wind directions, also usually very important when you're doing these measurements to give context. So that's one way to do the measurement here. I guess it's fun things you can point out to the students. It's not like when we're doing gas measurements or liquid concentration, you're talking about just the number over a volume. But since the number of particles can change, overall what you're more interested in is the mass, and that's why we do this mass over volume technique instead. So I think there's some descriptions of kind of understanding the difference between that here that you can share with the students as well in the classroom. So then there's also kind of a low budget way we can mimic that type of measurement. And so it uses a vacuum cleaner. Which, again, I don't know that there's any point in me going through the method because you're not really going to see it here. But, so you'll have one of these in your kit. We also have our own version of filter tape, like was described there, but it's an actual coffee filter. And we can use our bags again, which I left one over there. But basically, this activity is set up. Oh, here we go. And then these really fancy, high-tech, super precise balances we have. This little digital scale. Again, if you have access to a much better balance in your classrooms, go for it. But basically, the activity is set up that you're going to try to get a flow rate. You want to understand how much volume is being, you want to measure the volume of a certain container, if you will. And so we can use one of those bags that we just used to blow in the last activity, fill that up with air, kind of stick that on the end of the vacuum cleaner, and measure kind of how long it takes to suck that all the way through. And so using that information, you can come up with a volume measurement, right? That's like your flow rate, your volume that's passing through here. And again, all the calculations are explained here. And then what you can do is take some filter paper. Because these are pretty lightweight and on the scale, again, it's not necessarily the best way to measure this, but if you have a better balance, you can take either one piece of filter paper or a whole stack of them, measure the mass and then divide it by the number of filter sheets that are in that stack, if that's an easier way to do the activity. And then you're gonna basically try to collect some kind of particles on this filter right here by kind of holding it over the vacuum cleaner. And we can talk a little bit about some ways that you could do this a little bit better. I'm just giving you an overview of what the activity is. You kind of collect filter here, and you're hoping that you can collect particles You'll let this run for, I don't know, several minutes, an hour, or something like that, depending on how long the charge lasts. And you can try to collect particles that way. Then you would do a measurement of the filter paper after you've collected some particles on it. And now, you can have the mass difference. You got the mass, you've got the volume that you just calculated using the bag and the vacuum cleaner. So, does that make sense to folks?